This is Module 7, Section 2.5. In this section, we are going to discuss formulas and problem solving with formulas. Formulas are simply equations that represent a relationship. There is usually more than one variable in a formula. Depending on the problem, you may be asked to solve for a specified variable, and you want to isolate the variable you are interested in. And the way you're going to do that is with any other equation. You're going to use properties of equality, and you're going to use opposite operations to move stuff around and to get the variable that you're interested in isolated. So we're going to start with this example. This is a formula for volume of a rectangular solid. Volume equals length times width times height. And we want to rearrange that and solve it for h, which means we want h to be isolated. So in order to do that, notice that there are two things on the right-hand side that we're going to have to move so that h can be by itself. We're going to have to get rid of the length variable and the width variable. Both of those are being multiplied, and so the opposite of multiplication is division. So we're going to divide the right-hand side by both the length and the width. Notice that the multiplication property in between those two is still the same if you're dividing them both out in the same step, which you can do. According to properties of equality, if you're going to divide the right-hand side by length times width, you're going to have to divide the left-hand side by the same. What happens there is the length cancels out, as does the width, just as if those were numbers, and you're left with the variable h on your right-hand side. Now on your left-hand side, all of those variables are different, so nothing will cancel out. So therefore, you can just rewrite that, and that is your answer. Once you have your h isolated, your answer is v divided by L times W. All right, so let's do this one. Let's solve 2x plus y equals 12 for y. Now what that means is we want to get y by itself and move everything else to the other side. Therefore, we're going to need to move that 2x. That's a positive 2x, so to move it, we're going to have to subtract it from both sides. 2x minus 2x is 0x, and 0x is 0. So now we've got y on our left-hand side. Now on our right-hand side, 12 and 2x are unlike terms. You cannot combine them, and so we're just going to end up writing that as a subtraction problem since we can't combine them. Our y is now isolated, and we're done. All right, solve a equals 1/2 times b times h for b. Now there's a couple of different ways you can do this problem. I think the easiest way is to look at this side first. 1/2 times b times h is the same as 1/2 times b over 1 times h over 1. You can take any factor that is not a fraction and make it into a fraction by putting it over 1. Now when you do that, if you do straight multiplication, you've got 1 times b times h in the top, which is simply b times h, and on the bottom you've got 2 times 1, which is 2. And so our formula can also be written as a equals b times h divided by 2. All right, now at this point, we're clearing fractions. So just like with regular equations, to clear fractions, you look at the fractions in the entire equation. There's only one of them. Find the least common denominator, or the least common multiple, which in this case, of course, would be 2, and multiply each term by 2, whether or not it has a fraction. Remember, you have to multiply everything by 2. So the a also has to be multiplied by 2. Remember, terms are separated by addition or subtraction or equal sign. So this is all one term. You just need to multiply it by 2 one time. The 2 cross cancels out, as it should. So now you have, if we bring that up over here, 2 A is equal to B times H. Trying to solve for B, want B by itself, so we need to get rid of that H. That H is being multiplied. The opposite of multiplication is division, so we're going to divide it out. And our answer ends up being B equals 2 times A divided by H. And that's your answer, because there's nothing further you can do unless they tell you numbers to substitute in for some of those variables. All right, let's do this problem. Solve P equals RT divided by MV for V. Now I'm going to rewrite that so it looks a little more like a fraction problem. RT divided by MV. Trying to solve for V, which is down in the denominator. So just like with any equation, we are going to clear fractions first. So if you look in the denominator, that is the only denominator in the problem, so by default that has to be your least common denominator or least common multiple. So we're going to multiply both sides by M and V in order to clear fractions. Or another way to think about that is the opposite of division, and both M and V are being divided. The opposite of division is multiplication. So we're going to multiply both sides by MV. That will cross-cancel your M out. It also cross-cancels your V out. Now we've got, on the left-hand side, M times V times P, which is exactly that, M times V times P. And on the right-hand side, we're left with R times T. Now we're trying to solve for V. So in order to solve for V, which is right here, we need to get rid of both the M and the P. Those are both being multiplied, so the opposite of multiplication is division. So we're going to divide both sides by M and P. That will cancel out on the left-hand side. And we get a final answer of V is equal to RT over MP. And there's nothing further you can do, but you have isolated the variable that is asked for, and you're done. All right, let's look at this problem. Solve A equals P plus P times R times T. All right, we're trying to solve for R. So this term we want to get by itself to begin with. So we're going to move the P. That P is a positive P, so we're going to subtract it from both sides. P minus P is 0. On the left-hand side, A and P are unlike terms. You can't combine them, so you'll just have to rewrite them as A minus P. A minus P now equals what's left on the right-hand side, which is P times R times T. We want to solve for R, so we have to get rid of both the P and the T. So we're going to divide that out on both sides. Notice our P's cancel out and our T's cancel out. And we've got A minus P over P times T equals R. Now you can leave your answer like that. That's one possibility. Okay? Or you could take that a little bit further. If you want to, you can take that denominator and split it out to each of those terms up top. That would give you A divided by PT minus P divided by PT. The reason that might be helpful is notice in your second fraction now, because we have all multiplication and division, we could cancel our P's. And that would give us A over PT minus 1 over T. Any of these answers are okay. They're the same thing. The important thing is we have our R variable isolated. All right, let's look at this problem. C is equal to 5/9 times the quantity F minus 32. I'm going to rewrite that so my fraction looks a little more like a fraction. So 5/9 times the group, F minus 32. Remember when we were solving equations in Module 6 and we were clearing fractions, we said that when you clear fractions, you want to distribute that 5/9 to that group before you clear fractions. And so we're going to do the same. So we've got C equals 5/9 times F is 5/9 times F minus 5/9 times 32, or 32 over 1. That gives you C is equal to 5/9 times F minus, if you multiply across, 32 times 5 is 160, divided by 9 times 1 is 9. All right, now at this point, we've gotten rid of our groups so we can clear fractions. So look at the denominators of all the fractions. In this case, we've got 2 fractions, but they both happen to have a 9 in them. So to clear those fractions, we're going to multiply each term by 9. Remember, each term is separated by addition, subtraction, or an equal sign. So you need one multiplication by 9 for each of those. So we've got both sides. 9 times C is equal to 9 times 5/9 times F minus 9 times 160 over 9. Remember, those 9s are up in the numerator, and the purpose to that step is we should be able to cross-cancel out our denominators if we did that step correctly, and no longer have to worry about our denominators. So now we have 9 times C is 9C. That's equal to 5 times F, which is 5F, minus 160. Trying to solve for F because that's what the problem asks for, so we want to get that F term by itself. So we're going to move the 160 because the 160 doesn't have anything to do with the F. Now we have, and I'm going to bring this up here, now we have 9C plus 160, those are unlike terms, you can't combine them, is equal to 5 times F. All right, trying to solve for F, so we're going to divide both sides by 5. And remember, we said you can divide that entire left-hand side by 5 if you want, or if you want to, you can split that out into 2 separate fractions. That would be 9C divided by 5 plus 160 divided by 5 equals F, if you choose to split it out. And the only advantage to that is notice that this fraction now can be further simplified. Okay? You've got 9C divided by 5 plus 160 divided by 5 is 32. And that's equal to F. Your F is isolated, and your problem is done. Now we are going to use formulas to set up application problems. You are expected to know the formulas shown in the examples below. All other formulas will be given to you if they are required to solve the problem. Okay, so we're going to keep it simple in terms of what you have to memorize. The first type of formulas that I want you to be familiar with is perimeter of rectangles or squares, which are special types of rectangles, and triangles. The definition of perimeter is the distance around an object. So if you're talking about, for example, let's say a rectangle, you know that rectangles have 2 basic dimensions. They have a length associated with them, and they have a width associated with them. Now there are 2 other sides, of course, but in order to be a rectangle, the length should have a parallel side on the opposite side of the object that is the same. So if you have a length on the bottom side, you also have a length on the top side, and those would be the same length. If one is 5 inches, then the other is 5 inches. Width is the same way. You've got a width on the right-hand side, and so you would have a corresponding width, which I can't seem to spell. There we go. Corresponding width on the left-hand side as well. Again, if your width is 3 inches, then your other width is 3 inches as well. Definition of perimeter is the distance around that object. So it's an addition problem initially. If you think about measuring the sides of that object, you'd measure the length plus the width plus the length plus the width, and you would have added up all of the sides around the object. You would have the distance around the object, and that is the perimeter. So if we write that down, perimeter then, which is normally symbolized with a P, is equal to length plus width plus length plus width. And if you combine like terms there, notice you've got two like terms there. You've got one length plus one length. 1 plus 1 is 2 times your length. And you've got some like terms with your widths as well. 1 width plus 2 widths is 2 widths. So perimeter can be a straight addition problem, length plus width plus length plus width, or perimeter can be expressed as 2 times the length plus 2 times the width. A square is just a specialized case of that. Okay, if you have a square, you know that the definition of a square is that all sides are the same length. So we'll use S's there to represent that. So in this case, perimeter, thought of as an addition problem, if you just add up side lengths, would be side plus side plus side plus side. Or, if you combine like terms there, perimeter of a square, side plus side plus side plus side, is the same as 4 times your side. That's a specialized case of a rectangle. Triangles. Triangles can have sides that are the same length, but they aren't necessarily the same length, so we can't generalize quite the same. So we're just going to represent the side lengths of this triangle as A, B, and C. And again, if you're measuring perimeter, you're going to measure the length of side A, you're going to add to it the length of side B, and then to get all the way around that triangle, you'll have to add on the length of side C as well. So the perimeter of any triangle is A plus B plus C, where A and B and C are simply the lengths of the sides of that triangle. So perimeter is something that I would expect you to know. The second thing that I would like for you to know is the area of rectangles or squares. Okay? Now area, by definition, is the amount of surface of a region. So let's look at a rectangle example first. If you have a rectangle and that rectangle has a length, which will symbolize with an L, and a width, which will symbolize with a W as above, the definition of area mathematically is if you take the length and multiply it by the width, that will give you the area of any rectangular area. If you have the special case of a square, which again is still a rectangle, but it's a special rectangle, where both the length and the width are the same length, so we'll use S to represent that. Area, again, in general is length times width, but now we've got S's to represent that because length and width is the same length. And so here, area could also be represented as S times S, which is S squared. So that's a special rectangle where area of a square is equal to any of the sides squared. All right, so let's apply that. Here's an example of a problem you might see. You are purchasing carpet and new baseboards for your bedroom. The bedroom is 9.5 feet wide and 12 feet long. So the first thing we want to do, sorry about that. The first thing we want to do is find the area and the perimeter of the bedroom. All right, a picture is worth 1,000 words, so we're going to draw a picture here. We've got our rectangular bedroom. Our bedroom is 9.5 feet wide, so that's our width, and 12 feet long. That's our length. All right, we'll start with area. Area, we know, is length times width. So length times width in this case would be, our length is 12 feet, multiplied times our width of 9.5 feet. All right, now let's do the numbers first, because this is the first time we've really used units too much. If you do the multiplication of 12 and 9.5, you find that you get 144. I'm sorry, that's not right. It's 114. Okay, now units, if you take feet, if you think about units just like, say, variables, if instead of feet there you had x's, if you took x times x, that would give you x squared. Okay? Same thing is true with units. If you take feet times feet, then your units end up being feet squared. And so the area of this particular room is 114 feet squared. Perimeter, on the other hand, is simply adding up all the sides. So length plus width times plus length plus width, which in this case would give you 12 feet plus 9.5 feet plus 12 feet plus 9.5 feet. Okay, let's do the numbers first. If you take 12 plus 9.5 plus 12 plus 9.5, I believe you get 43. And again, thinking about the foot units as variables, if you were adding something that was, say, let's say 12x plus 9.5x plus 12x plus 9.5x, you'd think about that as like terms, and you'd say, well, that's 43 x's. Okay? In this case, though, we don't have x's, we have feet, but it works the same way. When you add or subtract units, okay, if you've got feet plus feet plus feet plus feet, the final value that you get is just a lot of feet. Okay? Apples plus apples plus apples plus apples is a lot of apples. Okay? So in this case, the units just carry on just like it would if that was a variable. Here, the units multiplied just as if those were x's instead of feet. X times x is x squared. Feet times feet is feet squared. All right, so now I want you to identify whether the baseboard has to do with area or perimeter, and do the same with the carpet. Okay? Does carpet apply to area or perimeter? Okay, baseboard is simply the little piece of board that's along the base of the walls around the room. Okay, so therefore, you would agree with me that the baseboard would be lining the side of the walls. If you had to go to Home Depot and buy baseboard for your room, the way you would figure out how much baseboard you needed is you would measure the length and width of each of those walls. So you would agree with me that perimeter deals with the baseboards, because you need to know how much baseboard to fit around the bottom of those walls or the outside of that area shown. Okay. Now carpet, you agree with me, is something that you're going to put down on the surface area of that square. Okay. So unlike just the outer edge of the rectangle, carpet has to do with the entire area that that particular object covers. And so carpet has to do with area, not perimeter. If you go in and order carpet, you'll tell them either how much square feet or square yards you need to purchase from them in order to cover the floor of your bedroom. All right, another example. Find the area and the perimeter of a triangular-shaped garden shown below, which I'm going to draw for you here. You have to know that the area of a triangle is equal to 1/2 times base times height, where B is the base leg of the triangle, or the leg that, if it was setting on the ground, the triangle would be setting on. And H represents the height of the triangle from the base to the top point. Describe a situation where you might need to know the perimeter and the area of your garden. Okay, so this is the garden that we're going to talk about. It is a triangular shape. Okay. Assume that the lowest side, if this was sitting on flat ground, represents your base. From the base, perpendicular to the tip of the triangle, so this is a 90-degree angle, this is the height of your triangle, up to the tip of your triangle. And you know the following. You know that this side on the left measures. Your base is going to be 25 feet. The third side of your triangle is 15 feet. And the height of your triangle is going to be 12 feet. Okay, given that picture, we're going to calculate the area and the perimeter of that particular shape. Let's start with area. You know that area is equal to 1/2 times base times height. Therefore, you have to know the base and the height, which we do. We've got 1/2 times our base length is 25, and I'm going to put that over 1 because I'm doing fraction work, times our height is 12 feet. Do the math. Note you can cross-cancel between the 2 and the 12 if you want, since that's all multiplication. I'm going to choose to reduce at the end instead. So we've got up top, we've got 25 times 12, which is 300. In our denominator, we've got 2 times 1 times 1, which is 2. And there, if you do your division there, if you didn't cross-cancel, and I didn't, 300 divided by 2 is 150. And units, remember that your base length had a measurement in feet. Your height had a measurement in feet. If you multiply those two together, just like with variables, x times x is x squared, feet times feet is feet squared, or square feet. So that's your area. Let's talk about what you could use that area for. Area of a garden, which means, of course, you are finding something to cover that ground in that particular triangle. One application might be if you had poor soil and you needed to purchase topsoil. Okay? You might have to know the area of your garden to purchase the correct amount of topsoil to cover your garden, because you want to spread it over that entire area. Okay, perimeter. Perimeter of an object is simply the distance around, so this is the easier of the two. If you walk around this particular garden, you've got 20 feet plus 25 feet plus 15 feet. So your perimeter is 20 feet plus 25 feet plus 15 feet. 20 plus 25 plus 15 is 60. And feet plus feet plus feet is just a lot of feet. Okay? Just like if that was 20x plus 25x plus 15x was 60x, 20 feet plus 25 feet plus 15 feet is 60 feet. An application for that, in this particular example, if you have a garden, perhaps you need to fence that garden to keep out predators, deer or rabbits or whatever. If you have to go to Lowe's to pick up fencing, you would have to know the distance around that garden to know how much fence you needed to pick up. All right, let's look at this problem. The length of a rectangle is 5 inches more than twice the width. The perimeter is 34 inches. Find the length and the width of the rectangle. All right, picture is worth 1,000 words, so let's start with that. If we've got a rectangle, This particular rectangle has a length that is 5 inches more than twice the width. Now notice that they have a problem that is referring the length to the width of the triangle. So I'm going to let my variable, the thing that I'm going to try to solve for, to be my width dimension. So I'm going to let x be my width, because I know that my length of this rectangle is 5 inches more than, so I'm adding 5 to something, 5 inches more than twice the width. Well, twice means multiplication, and twice the width, because I said I was going to let x be my width, that would be 2 times x. So just to clean that up, if x is equal to my width, 2x plus 5 has to be my length. Now, how does that help me? I know that my perimeter is the distance around my object. So if I walk around this object, I've got a length of x, and then I walk around that length, and that's 2x plus 5, so I add that on. And then I'm going to walk up that width, which also is x because it's a rectangle. And then I'm going to walk across that other length, which again is 2x plus 5. Perimeter says to add all of those dimensions together, length plus width plus length plus width. I know that my perimeter is 34 inches. So now, if I put 34 in for my perimeter, I'm now going to combine like terms. I've got an x here, so that's 1x, plus another 2 is 3, plus another 1 is 4, plus another 2 is 6 x's total. All I'm doing is combining like terms. I've also got a plus 5 and a plus 5 here. Plus 5 and plus 5 is plus 10, of course. All right, now I have an equation where I can solve for x. So, isolate your x. I'm going to subtract 10 from both sides. 34 minus 10 is 24, equals 6x. If I then divide both sides by 6, I find that, bringing it up over here, x is equal to 24 divided by 6, which is 4. For what? It'll be 4 inches, because my original length and width were given in inches as well. Okay, my perimeter is in inches. So, am I done? And the answer is no. That only gives me my width. My length is 2x plus 5. So, that would be 2 times 4 plus 5, which is 8 plus 5, which is 13. So that's my length. And so, I have a length of 13 inches and a width of 4 inches, and that's what the problem asked me to find, the length and the width of my rectangle. All right, another example. Given C equals 5/9 times the quantity F minus 32, find the temperature in Celsius, so they're asking us to find C, if the temperature in Fahrenheit degrees is 68. Now this problem is simply a plug value in problem and use orders of operation. Here's our formula as given. They give us a value to plug in for F. Notice that C is already isolated, so we aren't going to have to move anything around. Once we put our number in, and let's do that, we've got 68 minus 32. If we plug 68 in for F. C is already isolated, so now orders of operation. Do your group first. 68 minus 32 is 36. See, I'm going to bring this up here. (68 minus 32 is 36. That's a multiplication step. So notice that since it's multiplication, if you'd like to cross cancel, you can. In fact, let's do. If you look at the 9 and the 36, there's a common factor there of 9. So we're going to take a 9 out, top and bottom. 9 divided by 9 is 1. 36 divided by 9 is 4. Notice in our denominator, all we have left is 1s, so we can ignore that denominator and do the math up top. 5 times 4 is 20, and that is our answer. If you are at 68 degrees Fahrenheit, you are at 20 degrees Celsius. This is the end of Module 7, Section 2.5 material. You now should complete the homework for Section 2.5 found in my math lab, and when you have successfully completed the above homework, proceed to the video for Module 7, Section 2.7.